Hi guys, I wanted to make a quick video, just like a refresher video that you can watch before you take the test. I'm just going to go over a couple of problems from the review. These are some of the questions that you guys had asked me. So we're going to start with completing the square and I'm going to pose the problem. So the problem that we were working on was m squared plus 14m minus 13 equals -2. So some things to keep in mind when we're completing the square is number one, I'm going to change to black again. Number one is that C needs to be on the right side of the equal sign. Number two is that our A needs to equal 1. And then steps 3 is to just do half of B, so do B divided by 2. Then square that. Step 4 is to add it to both sides. Step 5 is to factor into your trinomial. And step number 6 is just to solve. So those are the steps that we're going to follow. I know I'm sorry that handwriting is a little bit janky, but it's kind of hard to write on an iPad versus a piece of paper. So if we're following our steps, C needs to be on the right side. So here's my C value. It's still on the left. I need to move it. So I'm going to add 13 to both sides. So when I do that, I get a new equation. And that looks like m squared plus 14m plus something, because I'm going to put something there, equals -2 plus 13 is 11 plus something else. So now I need to figure out what that something is. So I do half of 14, which is 7, and then I square it, which is 49. I'm going to add 49 to both sides. And then I can factor that perfect square trinomial, which is made up of my variable and whatever half of my B value was. So half of 14 is +7, so I do +7 squared. And then I'm going to do 49 plus 11, which we're all smart people. 9 plus 1 gives us 10. So we have 60 on this side. So 11 plus 49 is 16. And then we just want to keep solving. So if we continue solving here, we're going to square root both sides, square root. And then on this side, we're going to be left with m plus 7, and that's going to equal whatever the square root of 60 is. So remember, we don't want decimals. We want actual answers. So we need to break down that square root of 60. So we're going to think to ourselves, what is a perfect square that goes into 60? So if you pull out your handy dandy calculator, you can guess some things. So you can start with that smallest square, which is 4. So do 60 divided by 4. And I get 4 times 15. And I know there's no more perfect squares that go into 15. So that means this is going to break down to the square root of 15 and the square root of 4. And we all know what the square root of 4 is. That's plus or minus 2. So we're going to have plus or minus 2. The square root of 15 is that broken down square root of 60. Last step is just to continue solving. So when we do that, we get a final answer of m equals -7 plus or minus 2 the square root of 15. So this one's going to be our final answer here. So we made sure C was on the right side of the equal sign. We checked to see that A was 1. If A is not 1, then we have to divide by A. So if we had something where A was like 2 or 3, we would divide everything in the equation by that number. And then we take half of B and square it. Add it to both sides. That's what I did there in purple. Factor the trinomial. That's my purple, complete purple. And then I continued solving in that dark teal. So that's completing the square. I'm going to move on to some other questions that you guys had asked. So another one was how to solve something by factoring. So when we have a factoring question, I'm going to do number 6 from our problem set. So when we have a factoring question, number 6 said x squared plus 15x equals negative 56. So we want everything to be in the form, this is step 1, it needs to be in the form ax squared plus bx plus c equals 0. So what that means is we need our equation to be equal to 0. And right now, if we look over here at our equation, it's equal to negative 56. So that's the first thing that we need to change. So to get rid of this negative 56, we're going to add 56 to both sides. And when we do that, we get a new equation that looks like x squared plus 15x plus 56 equals 0. The next thing we need to think about is what two numbers can I multiply to get 56 but add to get 15? So we need to multiply to get 56, but then we need to add to equal 15. So if we think about some of the factors of 56, we have like 2 and 28. It's not divisible by 3. It's divisible by 4, and that's 4 and 14. Those two don't add to give me 8 or 15. It's not divisible by 5, not divisible by 6, but it is by 7, and we get 7 times 8. So 7 times 8 gives me 56, and then 7 plus 8 gives me 15. So my two factors here are going to be positive 7 and positive 8. So when I factor this, we'll have x plus 7 and x plus 8, and that's going to equal 0. So once we get to this step, this is where, if you remember, we're going to set each of them equal to 0, and then we're going to continue solving. So we're going to set x plus 7 equal to 0, and we're going to set x plus 8 equal to 0. And then we're going to keep solving. So we're going to subtract 7, and we get that x equals negative 7. And then we're going to subtract 8, so we get that x equals negative 8. So our two answers for this problem are x equals negative 7 and negative 8. So I had a really good question earlier from April. Shout out to April. She asked me why some of them had 2 answers and some of them only had 1. So if you remember when we started talking about quadratics, I said what we were solving for is where this is going to cross the x-axis. So in this case, when we have something that has 2, that means it's crossing the x-axis twice. So if you can see, this graph does not represent this equation, but I'm just showing you like a standard. This one has 2 solutions because it crosses the x-axis twice. Ones that only have 1 solution are where it just comes down and taps the x-axis and goes right back up. So this one only has 1 solution, which that can happen. It does happen, just not in the problem that we just did. So I want to do another factoring one with you guys, and then I'm going to do some of the other kinds that we had questions about. I'm going to try to do at least one of each problem. Some people had questions about number 5, which I can do, but that one is actually a completing the square, so I can go back and do number 5. I'm going to do number 8 from this factoring section as well, and that was x squared plus 36 equals negative 12x. So we need to make sure that our equation equals 0, and currently it equals this negative 12x. So first thing is to deal with this guy. So we're going to add 12x to both sides. And when we do, we create a new equation, which is x squared plus 12x plus 36. And again, that equals 0, which is what we were trying to get. And now we need to think of 2 numbers that are going to multiply to give me 12, but are going to add to give, or multiply to give me 36, but are going to add to give me 12. So when I think about 36, I know that there's 9 and 4, but that doesn't add to give you 12. There's 6 and 6. Does that add to give you 12? So mentally, you just need to start thinking of numbers and then arrive at the one that will multiply and then add to give you what you need. So we're going to have 6 and 6 here. So when we do that, we'll have x plus 6 and x plus 6 equals 0. And then again, remember from this step, we're going to set both of these guys equal to 0 here to figure out what x is. So we're going to do x plus 6 equals 0 and x plus 6 equals 0. And then continue solving. So we're going to subtract 6 from both sides. And we get that x equals -6. If we go to this other problem, again, subtract 6 from both sides. And we get that x equals -6 as well. So when I get something like this where it says x equals 6 and x equals -6, they're the same number. So really, x just equals -6. And this is an example of that second graph that I drew. So the first problem we did is an example of this graph here, where it has 2 solutions. And then that bottom example that we just did was an example of this graph where it only has 1 solution. Both are relative. So now let's talk about taking the square root. This is what we started with when we started doing quadratic equations. And we started solving these guys. So just starting out, I'm going to do problem number 11, which was 9m squared equals 225. So our goal here was to get our variable by itself. So right now I have it multiplying by 9 and being squared. So to undo that multiplication by 9, I want to go ahead and divide by 9 on both sides. So when I do this, I get m squared equals 225 over 9. And I don't want to simplify this because if you notice, the next step we're going to do is square root, and both of those guys are perfect squares. So to undo that square, like I said, we want to square root that. So we're going to square root. On the left, we end up with just m, and on the right, we get plus or minus. So if you remember, we break this down into the square root of 225 divided by the square root of 9. So the square root of 225 is 15. The square root of 9 is 3. I don't know why I wrote a 9 there. And then from here, what is the last thing that you can do? 15 and 3 have something in common. So we can simplify that. When I do 15 divided by 3, I get 5. So my answer here is m equals plus or minus 5. So we were really just solving that one. And if you notice what's different about this one compared to the other ones, is this one only has a squared term and a constant term. So this one only has an x squared and a constant term. Whereas all my other ones have had an x squared, an x, and a constant term. So if you have this, you're good to go. If you have this, do not do this. So another one I wanted to go over, let me pull it up real quick, was number 12. So number 12 said p squared plus 5 equals 38. So again, our goal is to solve for that variable. So I want to get rid of anything that's around it. Right now, the plus 5 is, so we're going to subtract 5 from both sides. And then we get p squared equals 38 minus 5, which is 33 for all you math wizards out there. And then we're going to do square root both sides because we want to solve for p. So when we do this, we get that p equals plus or minus. Now we're going to think to ourselves, 33 is not a perfect square. Are there any perfect squares that go into 33? And our answer here is no. So we just leave it as plus or minus the square root of 33. Perfectly acceptable answer. So we could have whole numbers or we could have these irrational numbers. where they're still in those square root symbols. The last problems that I wanted to talk about today were the quadratic formula problems. So this is our newest content. This is mostly what we have done online. So I wanted to go over one with you guys just so that you kind of have it fresh in your memory when you go to take the test. Also, do not worry, I'm going to allow 2 attempts for the test. So at the end of your first attempt, you can go back through and see the ones that you missed and then kind of redo those problems just to get your best score possible. Because I know that this whole online learning thing is hard for everybody and we're all trying to get used to it. So I wanted to cut you guys a little bit of slack and give you a little bit of a break, but still check and make sure that you're understanding what we're going over. So this last problem I'm going to do is number 16 from the review. And it says x squared minus 12 equals 8x. So again, when we do the quadratic formula, we want everything to be in form of ax squared plus bx plus c equals 0. So we want our equation to equal 0. And right now it equals 8x. So to get rid of that 8x on that right side, we're going to subtract 8x. So when we do that, we get a new equation, which looks like x squared minus 8x minus 12 equals 0. And then I'm going to come over here again and I'm going to rewrite that quadratic formula just so that everybody has it. So x equals x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. And if you remember, we also talked about that thing called the discriminant. And the discriminant told us how many solutions we were going to have, and that helped us determine how many and what kind. So when we did this, our discriminant equaled b squared minus 4ac. So just for the practice, I'm going to do the discriminant as well as the quadratic formula. So when we do the discriminant, we have to identify our a, b, and our c. So our a here is 1, our b is negative 8, and our c is negative 12. So when we go to plug these into our discriminant, that's the numbers that we're going to use. So we're going to use negative 8 squared minus 4 times my a value, which we said was 1, times my c value, which we said was negative 12. So far, so good. So what happens next is we just continue to solve. So negative 8 squared is positive 64. And then negative 4 times 1 times negative 12 is positive 48. So we have 64 plus 48. So when we do this math, we'll do this math real quick. 64 plus 48, we get 112. So our discriminant is positive, okay? So discriminant, if it's positive, then we have 2 real solutions, if you remember. If it is 0, we have 1 real solution. And if it is negative, we have no real solutions. So this was in the notes. You will be asked a question about this tomorrow on the exams, or, well, I guess it's today for you guys. But just keep that in the back of your mind when you have a discriminant. If it's positive, 2. If it's 0, 1. If it's negative, none. So now all we are left with to do is to plug all this information into our quadratic equation and figure out what those 2 real solutions are. So I'm going to go ahead and set this up with x equals the opposite of my b value. So my b value up here is negative 8. So I'm going to put 8 plus or minus the square root of my discriminant, which we just found was 112, all divided by 2 times my a value, which we said was 1. And then we're going to continue solving. So the only thing that we can really do is figure out a perfect square that goes into 112. So we need to break down that square root of 112. So I'm going to start running through some of my perfect squares. I'm going to start with 4 and 28. 28 is still a pretty big number, so I'm going to keep going. I'm going to do 112 divided by 9, which those two don't go into each other, so we can't do that. 112 divided by my next perfect square would be 16. And here I get 16 and 7. 7 is a fairly small number, so I kind of like that. I'm going to stick with that. So we can break this into the square root of 16 and the square root of 7. Because again, 16 times 7 is 112. And 16 is a perfect square. So that makes me happy. So when I go to simplify this, the square root of 16 is 4. We don't know what the square root of 7 is, so we just leave it. So this is what we're going to replace that square root of 112 with. So I'm going to come back over here and I'm going to say x equals 8 plus or minus 4, the square root of 7, all divided by 2, because 2 times 1 is 2. Last step is to think if there's any more simplification that I can do. So 8, 4, and 2 all have something in common, which is the number 2. So we're going to take a 2 out of everything. So if I take a 2 out of 8, I am left with 4. If I take a 2 out of 4, I am left with 2. So our final answer here should be 4 plus or minus 2, the square root of 7. So you guys should watch this video. I will also upload some of these problems, or the screenshots of all of these problems, so that you guys can take a look at them after you watch the video. But we did do a problem with completing the square. We did do two problems about factoring, 2 problems on taking the square root of something, and 1 problem on the quadratic formula. If you have any more questions, please reach out to me. Also, a big reminder for the test, you will have to submit your work. So you take the test under the Unit 8 test tab that I will post in this week, and you post your work in the Friday tab. So once you take the test, click on the Friday tab, submit your work, take a picture of it, submit it, or you will lose 2 points. Please do not make yourself lose 2 points because you did not submit your work. If you have further questions, please let me know. And good luck on the test. Remember, you get 2 attempts.